Hello and welcome back. Today we're going to be talking about lists in Python. So the question we're addressing is how can I store multiple values in a single variable? And our learning objectives are to explain why programs need collections of values, and to write programs that create lists, index them, slice them, and modify them through assignment and method calls. Okay, so we've already learned about different data types in Python, such as strings, characters, floats, and ints or integers. Today we're going to be learning about lists, which allow us to store many values in a single structure, whereas with strings we only store a single string, ints or floats we only store a single value. To show why this can be useful, why we want to use lists, take this example. So we're using the Gapminder dataset now, and what we see in this first cell are the life expectancy values, so the average life expectancy for somebody living in Canada in different years, between 1900 and 2000 in 20-year increments. So I've stored each one as a value in a separate variable name with clear names such as life exp 1900, 1920, etc., etc. You can tell these are floats because they have decimal points, like 48.1. So I'm going to run this, CoCalc is going to warm up and eventually show that it's completed with a little 1 there. So we've stored those values each in a different variable name. So it requires a lot of variable names, and you could say there's structure in the data in the sense that each one of them stores a single value, each variable that is, and the variables are clearly named. There's no structure in the way they're stored, right? So each of those is a separate variable in Python, and Python doesn't know the difference between those variables and any other variables that I define. It doesn't know that those 6 values are actually part of one data set, and they have some relationship to each other. That's where lists come in. So lists allow us to store many values together, and the way we do that is we define a variable name, like life exp, assignment operator equals. So this is all very similar to the way we've done variable assignment in the past. But now we open up a set of square brackets and we just type the values that we want to store in the list, like 48.1, and separate each value from the other ones with commas. So 56.6, comma, 64.0, comma, 71.0, comma, 75.2, comma, 79.2. And then we close the square brackets, and Jupyter automatically does that for us when we start typing the open square brackets. All right, and then on the next line, I'm going to ask it to print out, and then the string life expectancies, comma, and then the name of that variable, life underscore exp. So we run that, and you can see the output. So it represents that list just the way we typed it in, as a series of values inside square brackets separated by commas. And like strings, we can use the len function to get the length of a list. So a list has length because it has multiple items, and the length will tell us how many items it has. So print, and then in quotes, length, comma, and then len, the function for length, parentheses, and then the argument that we give to the len function is life underscore exp. Run that, and the answer is 6, and indeed there are 6 values in that list. Okay, so that's an example of a list where all of the values it contains are floats, floating point numbers. But in fact, lists can contain values of all different types. There's no restriction that all the types of the different items in a list have to be the same. So here, for example, we can say personal underscore info equals, open our square brackets for a list, and we're going to save in this list a number of values, so with labels. So first name, I'll do it uppercase so I have it there, and then the second item, so comma, and then stanza. So these are strings, right, because they're enclosed in quotes. And then another thing about Python is, in general, you can continue the same line of code across multiple lines just by hitting enter. So that's what I did there. You can see my square bracket, closing square bracket moves down. And this allows you to sort of format and organize your code in a little more clear way. So what I'm doing here is saying first name and the associated first name are on the first line of the list, last name, and the person's actual last name, Ragnall, is on the second line. Hit enter again. Now we're going to store age, and here we're just going to give it the value 42 without quotes, so that means it's going to be represented as an int, an integer in Python. And then height, again a string, but the value of height is going to be 1.65, so a float. And then children, and Costanza actually has 2 children, so we're going to actually store the names of both children in a single list item, which itself is a list. So we have one list embedded in another list. Because lists are another data type in Python, a list can contain any other data type, so we can embed them like this. So we're going to have 2 strings in here, Apurva and Columbanus. Okay. And I'm going to hit enter right at the end of that, the close brackets for the embedded list. So the close bracket for the personal info list is on a new line, all on its own. So again, this helps with readability of the code. Okay, so execute that cell. It stores it. All we did was assign those values to the list, so there's no output. But now we've stored it. And indeed, if I wanted to ask what is in personal info, type it correctly. You can see I got a name error because I typed the variable name wrong. Okay, and it shows me all of those things. Another thing about lists is because they're a collection of items, just the way strings are a collection of characters, not only do lists have length, but we can also index them. So we can reference specific locations within the list, specific positions in the list by their indexes. As with strings, the indexing starts with 0 in Python. So we can use this example, element equals carbon. This is just a review of how we index strings, which we covered in the previous lesson. Okay, so 0th element, 0th character, and I forgot to put that in quotes. Character colon, comma, and element 0. I'm not going to run the second line or even type it. We did it last time. Hopefully you remember how it works. Okay, so again, Python counts from 0. So carbon is, the C is in position 0, A is in position 1, R in position 2, B in position 3, etc., etc. So this works the same way in lists. So if I ask Python to print, and we're going to print out the text 0th element, I can call it item, I call it element item in life underscore exp colon, comma, and then the next thing we're going to give to the print command is life underscore exp square bracket 0. So we use that square bracket to index the position in the list. We also use square brackets to represent a list, right? But the difference in why Python knows we're doing indexing versus defining a list is when we're defining a list, we give a variable name and then the equals operator, the assignment operator, and then the list items in square brackets. When we're doing indexing, we give the name of a variable that we've already defined, no space, no equals. Immediately after the name of the variable comes the square brackets and the indexing information. I'm also going to ask it to print out the 4th item of life exp. exp square bracket 4. Okay. So the 0th item, the one in the first position, is 48.1. 4th item is 75.2. And just like we can index lists and strings, we can also slice lists the way we slice strings. So before we learned about using the colon to specify a range of values that we were going to get when slicing a string. Same thing goes for lists, and the same rules apply, that when I specify a range, say in this case from 0 to 3, 0 colon 3, I get items up to but not including the 3rd item. So I get 0, 1, and 2 but not item 3. So here's what it looks like for lists. I'm going to print first 3 items in life underscore exp is life underscore exp square bracket 0 colon 4. And just as a second example, last item in life exp is life underscore exp. And remember, we can index from the end of a list using the negative values. So -1 would be the last item in life exp. And I just failed to put the quote at the beginning. Again, Jupyter's syntax highlighting is really useful because I could tell that because this line of code before was red, and red is reserved for items that are inside quotes, essentially strings. Okay, so I run that, and you can see first 3 items, 0, 1, 2, and 3. Maybe that's not the right way to write that. I should probably write that as the first 4 items in life exp. Even though they go up to index 3. Again, this 0 indexing is a bit confusing sometimes. And anyway, the last item in life expectancy is 79.2. We can also use indexing to replace a value in a list using indexing plus assignment. So look at this, life underscore exp square bracket 0. So I've got my square brackets, right? So this is indexing right next to life exp, no space, specify location, then the assignment operator, the equal sign, 48.3, and print life underscore exp. Okay, so before the first value was 48.1 and then 56.6. Now we changed the first value, so it's 48.3. All the other items are the same. So it's not like we inserted a new item and everything got moved over. We actually replaced a value within the list simply by giving it an index and then the assignment operator to assign a new value. You can actually increase the size of a list, so add items to it once you've created a list using the append method. So here we say print life exp, just to remind ourselves what it's like when we start running this cell, and then life underscore exp dot append, and then parentheses 82.3, and then again just print life underscore exp. So you can see that what we did when we did dot append 82.3 is it just added 82.3 to the end of that list. So the dot append method brings us to a discussion of what exactly are methods in Python. So far we've learned about functions, which are things like print and len and type. So those are commands in Python that you type the name of the command and then it immediately followed by parentheses, and any arguments that the command takes are in those parentheses. Methods are different. They're like functions in that they're commands in Python that do things, but they are run not by typing the name of the command and putting the arguments in parentheses, but they apply to variables. And they're done by using this dot syntax. So we have life expectancy in this example, the name of the variable, and then a dot, and then the method append, and then the argument to that method. So like functions, they still have arguments in parentheses. The difference is that you're actually specifying the variable name and then a period and then the name of the method. One difference between methods and functions then is that methods are tied to the type of object. So for example, .append is a list method. It applies specifically to lists. It doesn't apply to other data types that we've learned so far, such as floats or ints or things like that. We'll see other methods as we go along, and the nice thing about methods compared to functions in Python is that because they are tied to specific data types, you can have methods that are more customized to the nature of specific data types. So for example, a float is only a single value, and so it doesn't make sense to even have an append method or an append function for floats. So having these methods is a way of sort of tying the specific method to a specific type of object in Python. By the way, we can use help the help command, and then list. And we've seen the help command before, and we saw that it shows you the API, so the name of the function and all of the different arguments that it takes. When you run help on a data type like a list, you get slightly different information. It tells you what it is, tells you what happens if you don't give it arguments, and then it actually shows you all of the methods that are associated with that. The methods that start with underscores you can pretty much safely ignore for now, but the other ones starting here, you see there's list.append, list.clear, list.copy, list.count, etc., etc. And the help tells you what all of these do. So we're not going to go through all of them right now, but just to know that that's how you would figure out what methods are actually defined for a particular object or data type, and how you would understand what they are and what they do. Okay. Many methods, like the .append method, modify a data object in place. So let me scroll back for a moment and point out that when we ran life expectancy.append, we didn't use the assignment operator. So we didn't actually say something like life exp equals life exp.append 82.3. We just ran that command. And in fact, this is the right way to use a method. As I show in this example, life exp equals life exp.append. When you run that method, it actually returns a none. And so if you were to run that and print life exp, you would actually end up with a resulting value of none, which is not what you want. So in other words, let me try running that. Life underscore exp equals, you know what, actually I'm not going to do that because that'll break the life exp that I already defined, and I don't really want to do that. So instead I'm just going to say, we'll just call it junk equals, so I'm going to assign the result to something else. Life underscore exp dot append 82.3, and then print junk, and you see that we get the output of none. Okay, so extending a list. The append method only allows you to add a single item to the end of the list. So we added the value above, 82.3, but we can't add several values at once using the .append method. For example, look what happens when we do life underscore exp underscore 2000s. So we create a new variable. It's a list, and its values are 85.1, 87.3, 89.5, and 91.6. Okay, so a new list of new life expectancies for the millennium after the century after. And then we do life exp dot append life underscore exp underscore 2000s print life exp. So you can see that we get our original life exp list, and up above I'd appended 82.3 two times actually, so it's in there twice. But then you can see this life exp 2000s that we just appended gets appended as a list. So we get all of those values, but they're actually represented in this other list as a single list item, which itself is a list. So it's a nested list. That's not what we wanted. We wanted to just have what's called a flat list, where each entry in the list is a single value. So we can do this with a different method in Python, a different list method, which is called .extend. So again, and I'm going to cheat and copy and paste these two list definitions, if I can. There we go. Okay, so because I messed with life exp up above, I'm just redefining it here, and then we'll run this life underscore exp dot extend. And again, we're not assigning the output of this to a new variable or the same variable. We're just running the method, and it will apply in place. Life exp underscore 2000s. And now again, print life exp. Okay, so now you can see we get this flat list where each of the floats is just a list item. And our new list that we appended for the 2000s, they're just more values in there. So append and extend both add to the end of a list, but we can actually insert a new list entry at a specific position. So above I showed that you could actually replace a value in a position using indexing. We don't want to replace, we want to actually insert something at a specific location. So we can use the dot insert method. So life underscore exp dot insert, and the insert method takes two arguments. The first argument is the position in the list where we want to insert the new value. So we're going to say 0 to add it at the beginning of the list. And then the second argument is the new value that you want to insert, which is 46.9. Print life exp, and you can see that compared to up above where the first entry in the list was 48.1, now that's become the second entry, and the first entry is the one we just inserted, 46.9. Another thing we can do is use Dell to remove items from a list entirely. Dell is actually a little different from either a function or a method in Python. It's actually called what's called a statement. The way you know it's different is that you can see here, we run that Dell command with a space after it before the argument that we want to give it instead of parentheses. Why this is and the differences between statements and functions in Python we're not going to go into right now. You won't encounter very many statements in this course, so I wouldn't worry about it too much, just to know that Dell is different. There's a space, it's just a different way of doing things. Okay, so we have life exp, if you see these lines, and again I'm going to copy and paste some of the text here just to save time typing. Okay. But the critical thing to notice here is in this new version, and this is why we're running it again instead of relying on what we'd already typed up above, is life exp ends in 82.3, but then the first entry in life exp 2000s is also 82.3. So this is an example of where maybe we have a redundant value and we don't actually want two copies of that value in our list. So we're going to say life underscore exp dot extend. So we're going to merge these two lists together, extend life exp by life exp 2000s. And then we're going to print, because we know it's duplicated, with duplicated value, life underscore exp. Okay, and then we'll run this del command, so del for delete, life underscore exp, and indexing to give it the value. We know it's 6 that we want to remove just by looking at the list and counting. So 0, 1, 2, 3, 4, 5, 6. We could say 6 or 7 because they're redundant. We just have to pick one of them. And then we say print removed duplicate value life underscore exp. All right. So here's the first case with 82.3 twice. Then when we print that out again after running del, we only have 82.3 one time. Great. Another thing to know is that there's such a thing as an empty list. So an empty list is defined just by giving it empty square brackets. So x equals open square bracket, close square bracket. And then we can work with that list later and append things to it. So let's say y equals 1. And we can say x dot append y. And then we can say x dot append y plus 7. And then let's print x. So we're doing two appends, so we're appending two different values to x. First one's going to be y, so it should be 1, and the second value in the list should be 1 plus 7 is 8. And indeed, that's what we get. So in this trivial example, it may seem a bit silly to define an empty list and then add things to it. But even here, you can see that maybe we want to use the same variable y a couple of times in different ways to build a list appending different values to it. And once we learn more about things like loops in Python, you can see how this can be a powerful way to create an empty list as sort of a storage container do some stuff, often repeatedly many times, and add the results each time to that list and build it out that way. So there is such a thing as an epi list. It's good to know that. Okay, next topic is to think about differences between strings and lists. So both strings and lists are called collections in Python, which means that they can be indexed and they have lengths. Indexing works similarly for strings and lists, but the two data types are different in other ways. So one important thing to know is that strings are immutable. Once you define a string, you can't change it. So some of the things that we've seen here, like extend and append and Dell, you don't do to strings. String is considered a single value with parts, not a collection of values. In contrast, lists are mutable. Mutable means changeable. If that word seems unfamiliar to you, think about the word mutant. Mutable, mutant, changeable. Okay, so we can change lists in various ways. We've seen some of these already by like specifying an index for a specific element in the list and assigning a new value to that index, using append or .extend, or deleting items from a list with Dell. So because above we defined element as a string, just to prove that this, what I'm saying, doesn't work, remember element was defined as carbon, all lowercase. So I can try and now say element square bracket 0, so the 0th element, the letter C was put there, is a capital C. And run that. Type error, string object does not support item assignment. So we get an error because you just can't do that. Similarly, element.append, mint.append, and let's try and append, I don't know, it doesn't really matter, the letter S. We get an attribute error. String object has no attribute no attribute append. So those methods that you can apply on lists and other objects, as we'll learn later, are treated as attributes in Python. So again, sometimes you get this error message. It has a word that you don't recognize, like attribute, but if you sort of step back a bit and look at this error message, you realize string object, like append, doesn't work for strings, is basically what this error message is trying to tell you. Another thing to know is that there's such a thing as an index error, and you can get that if you try and index beyond the end of a collection. So for example, print the 99th element of life_exp is life_exp square bracket 99, because that's how we index, right? We get an index error, list index out of range. It's in a sense not surprising because we know that doesn't exist, but that is a difference between lists and strings, because before, when we were talking about string indexing, if you go beyond the end of the string, Python doesn't do anything. It doesn't throw an error, it just kind of ignores you. Okay, so that's the end of our lesson on lists, and now we have some exercises. So as usual, I'm going to encourage you to pause the video, work on these exercises, one at a time if you want, or go through them all, and then unpause the video and I'll walk you through them. Okay, so working through the exercises now. The first one is fill in the blanks. Fill in the blanks so that the program below produces the output shown. So we have a number of blanks there, and we want the code to eventually say first time is a list 1, 3, 5, second time 3 and 5. So how do we go about this? Okay, so what we're seeing here is that the code, there's an initial assignment of some value to values, and then other spots where we're going to be running some sort of method, and the arguments to that method are 1, 3, and 5, which are the elements of the list. So logically, sort of working backwards, I would think that the first thing I want to do is define an empty list as values. It's empty because the 3 values we want when we run the printout first time are 1, 3, and 5, and those are all going to be assigned later, so we want to start with this empty list. Okay, and then values dot tells us we need to use a method, and it's going to be the append method because we want to add these values to these actual values to the variable called values. Values dot append. First command is 1, Second one is values.append 3. And finally values.append 5. Okay, print first time values. Okay, so that should print out 1, then 3, then 5. Okay, then we want to do something that removes the 1 from that list so that when we run the second print command second time, only 3 and 5 are in that list. So how would we do that? Values equals values and something in square brackets. So there's no method that's being suggested here, so there's no dot blank, it's just something in here. So what we can use to remove the first entry in the list is slicing with a range. So we're going to say 1 colon. So remember Python index is from 0, so the 1 in this list is in position 0, 3 is in position 1, 5 is in position 2. So if we say 1 colon, that means take elements from 1 to the end, and only those elements. And we're reassigning that back to the same variable name, values. So then print second time values. Run that code, and we get the right output. Now, there are certainly any number of ways you could achieve the same output in Python, but because of the way this fill-in-the-blank assignment was sort of structured with the dot, blank, and then these individual things, and then the values as sort of square brackets and a blank, so suggesting indexing or slicing, this is the correct way to solve this particular problem. But certainly we could have just, for first time, we could have just run values equals square bracket 1, 3, 5, skip these dot append commands, run that first time with values, and it would have printed out right. To remove the first element, we could have used Dell, Dell values square bracket 0, or some other things could have also achieved the same result. But this is the way the problem was designed. Okay. How large is a slice? So imagine we have a list like life_exp above. If a and b are both non-negative integers, so we're doing algebra here, say a is equal to 2 and b is equal to 5, how long is the list life_exp a to b? And there's a code cell here, so you could work that out, but hopefully you took the time to think through that question first, because it's a question you can answer without actually running the code based on what we've learned so far. So if we say life_exp 2 colon 5, you get the elements in that list, including element 2, 3, and 4, but not 5. Because remember, the slicing operation takes from the first index you give it up to, but not including that last index. So I can confirm that by saying life_exp 2 to 5, and you get elements 2, 3, and 4, but not 5. You only get 3 results. We could, based on the way that problem's worded, we could also say a equals 2, b equals 5, and then use those variables in our slice. life_exp b a colon b, and you get the same result. Okay, solution was there anyway, so you probably figured that out already. Next one is going from strings to lists and back. So there's a list function. What do you think that does when applied to a string? Well, it probably makes it into a list, right? So what happens if I say list tin? We get the string broken down into a list, so each element in the string becomes a list item, separated by commas, and they're each characters because they're in quotes. What does the join method do? And this is an interesting one because you see here there's empty quotes dot join. Right, so let's just run that as it's typed there. And notice that what we're given dot join is a list of characters. So G, comma O, whoops, comma L, each one in quotes, and D. We get gold. So this interesting thing here is that we have these quotes with nothing in them dot join. And for some methods like .join, that's an acceptable thing to do, is give it something empty. In this case, though, the quotes tell Python that it's a string, right? Because the Python type that you specified using quotes is a string. So it's just an empty string, just like we saw empty lists up above. And we run the .join on an empty string. We join together those 4 character elements and we get the string gold. Okay, here's another one, slightly different because we put a character inside the quote marks. So put a hyphen dot join, and then the same but it has to be in square brackets because we're giving it a list, G, O, L, and D. So it joins those list elements, but it separates them with the hyphens. So it doesn't actually just sort of append or something to that string that you give it at the beginning. It actually uses that as a separator between the list items, but your result is still a single string. You can see it starts with quotes, everything is contained in one set of quotes, and then the end. Okay, moving on, talking about indexing. We can index from the end, and this one should have been pretty easy, I hope, because we've already talked about indexing with negative values, more in the context of a range. So you can go, life exp 0 colon -1, and it goes to the end of the list. Here we're using that in indexing rather than slicing, but same thing. So again, life exp equals 48.1, 56.6, 64.0, 71.0, 75.2, 79.2, and 82.3. And then we just say print life exp square bracket -1. Okay, so how does Python interpret a negative index? Well, it just indexes from the end of the list rather than from the beginning of the list. So the most negative index that can be safely used with anything is basically the beginning of the list, right? So if we start with -1, and that represents 82.3, in this list, -2 would be 79.2, -3 would be 75.2, -4, -5, -6, -7. So just to kind of, let's add a cell up above. What if we actually, and I'm not even going to, because I'm just running one command within the cell, I'm not going to use the print. I'm just going to say life exp -2, just to make that point, 79.2, -7, 48.1, that's our list element. What's going to happen if I go overboard? -99, or even just -8. Again, like we saw before, we get an index error. So you can't go indexing or slicing forward beyond the end of the list. You can't also go backward before the start of the list. And then the last question here is, how can you display all elements but the last one in a list? And the hint is you need to combine slicing with negative indexing. And you can see the answer down below. Oh, I missed the question about what does Dell life exp -1 do? Well, the answer is there. Fairly intuitive, I think, but because Dell removes whatever element you're talking about. So life exp -1, and then let's print life exp again. And you can see it subtracted that last element, the 82.3. Okay, and then for the final question, how do you display all elements but the last one? So we would do life _exp square brackets, and we want to go colon -1. What's that going to give us? See, that's going to go up to but not including the last element in the list. So it gives us 75.2 as the last item in the output, dropping that last one. Okay, here's a new bit of slicing syntax to play with. Let's just quickly, and again, lazy, copy and paste. I don't really like that CoCalc opens up those markdown cells when I click in them, but I guess that's what it's supposed to do. Okay, so what if we print parenthesis life underscore exp square bracket colon colon 2 and print life exp square bracket colon colon -1. Okay, so colon colon 2 gives us the output 48.1, 64.0, 75.2, 82.3. If you look, 48.1 is the first element, 64 is the third element. So what that colon colon syntax is telling us is we have the same first colon is specifying the range, but if you add a second colon and a number after that, that's the step size. So in other words, we're stepping through that list with every second item returned rather than every item. And if we say life exp colon colon -1, what happens is we actually end up reversing the list. So 48.1 is actually the first item in the list, but it appears last. So we're stepping through the list in step sizes of 1, but the -1 tells us to go from the end of the list to the start of the list rather than the normal way around. And there's some other examples here. So we can combine stepping with slicing. So if I say, and again, I'll just skip the print command and just say life exp square bracket 1 colon colon. So the first 1 colon means go from the first element in the list, so not the 0th element, but the first element in position 1 to the end of the list, and then the next colon. And then let's give it a step size of 2. So now we start with the second item, but we're still stepping through. So it's 56.6, 71.0, 79.2. Right. Next topic is slice bounds. So if we define life exp again, we keep redefining life exp just because then we do crazy things that modify it. So whoop. Let's just copy that list again. Oh, I didn't really need to hit enter there yet. Print life exp 0 to 20. So there's clearly not 20 items in there. And another one, print life exp square bracket -1. So start with the last element and go to element 3. So even though above we saw that we get an error if we try and index a particular single element outside the range of items in the list. So for example, print life exp square bracket 20 would fail. When we're slicing, we can actually specify a wider range and Python will just give it those values that are included. And the difference is that when we say 0 to 20, well, there are some items that there is some content there that Python can return. Whereas we just index position 20, or even if I said there's 6, 7 elements in that list. So if I said go from 10 to 20, it just gives us empty, and -1 to 3 also gives us empty. So when you're slicing with a list, you give it a range. If that range doesn't include items in your list, Python just returns an empty list. A bit of a sort of quirk maybe. You would expect it would throw errors both when indexing single items and when doing ranges, but it doesn't. Okay, so now we get into some fun little challenges. So what do these two programs print? And really, because we're using a new function here, sorted, and a new method, .sort, you could probably guess that they're doing something around sorting the arguments that you give them, or the items you give them. But let's just run those to see what actually happens. Letters equals list gold. So we're taking a string gold, and we've already seen the list function chops that up and returns a list with G as the first element, O as the second element, etc., etc. And we're going to define a second variable, letters underscore S equals sorted letters. And let's print letters is letters, and letters S is letters S. Okay, so letters, we break it into G, O, L, and D. Then we run sorted on letters, assign that out to letters underscore S, and maybe not surprisingly, now the letters are sorted alphabetically. Okay, so that's what the sorted function does. What does the dot sort method do? So again, letters equals list gold, letters underscore S equals letters dot sort. We don't give it any arguments, so it's empty parentheses. And again, we'll say print letters is colon letters, and then in quotes, and letters S is colon comma letters underscore S. So why did this happen? Well, the solution's below, but we do encourage you to think of these things before you look at the answers. But remember that functions generate output that would then need to be assigned out to another variable name. So when we ran the sorted function on letters, we assigned the output to letters S. List methods tend to apply to the list in place. So when I ran letters.sort, it actually sorted the letters list. It didn't sort, it didn't generate a new output. And remember that the output of list methods tends to be none. And that's why when we assign the output of letters.sort to letters underscore S, letters S is none, whereas letters became DGLO. So again, an important thing to keep in mind is that functions tend to produce output that you want to assign to a new variable, whereas methods often modify the input in place and generate none as an output. Okay. Here's another interesting and important topic in Python, and this applies here when we're talking about lists, but it's also a consideration for many other Python data types. And it has to do with when we make copies of variables. Sometimes things are copies, sometimes they're not copies per se. Okay, so program A, let's just type this in and run it. Y equals list gold. It's a string, so we'll get a 4-element list, G, comma, L, O, comma, L, comma, D. And then we assign X to be equal to Y. And then we modify the 0th element of X, and we assign to it the new value D. And so intuitively what we'd expect is that Y is going to be G-O-L-D, but X is going to be capital D-O-L-D. What actually happens? Print X is, comma, X, oops, and Y is, comma, Y. X and Y are both capital D-O-L-D. Why did this happen? Well, it's because when we do this assignment, X equals Y, Python's efficient. So, of course, when you do this assignment, Python is remembering what value you assign to a particular variable. It's held in memory, so in the RAM of the computer that it's running on. When you do this kind of assignment where X is equal to another variable that's a pre-existing variable, Python doesn't actually make a copy of Y and call it X. X just becomes a pointer to the same information in the computer's memory as Y, because that's more efficient. It's the same information, X is equal to Y, so they're the same, so why would we have two copies and use twice as much memory for that object when we can just point two different variable names at the same thing? The classic sort of Shakespearean, a rose by any other name would smell as sweet. We can call something different things and they all refer to the same object. Python does that same thing. Now let's do something a little different. Y equals list gold. X equals Y square bracket colon. So this is almost the same as the above command, but instead of saying x equals y, we're using slicing. And we're using slicing just with a colon, which tells Python take the entire contents of the list y. And then we assign x0 is equal to capital D. And now we print again x is x and y is y. Now they're different. And that's because when we say y square bracket colon, we're doing slicing. In this case, the slicing is the entire list y, but in principle, doing that slicing, you could be selecting a subset of the elements of the original y list. And Python just doesn't go so deep as to figure out if you're copying or sort of referencing all of the elements in the list or just some. It just sees that you're doing slicing. It knows that there's a chance that you're referencing only some of the elements of the list and not all of them. So it makes a copy of y and assigns that to x. So now x and y have, different representations in memory, and modifying x doesn't also modify y. Maybe a bit surprising, but this is something to get used to because in Python there are often cases where you do this kind of assignment of one variable to another and it makes a copy. Other times where it's just two pointers to the same location in memory. And so it's important to know that that could happen at least. Keep an eye out for when it does. And remember that there are tricks like using this square bracket with the entire range if you really want to force a copy. Turns out there's other ways as well. For example, there's actually a .copy method. So I didn't have a cell here, but I'll make one. So y equals list gold, just like we were doing above, x equals y dot copy. And so in this case, we're assigning the output of y dot copy to x. Above, I've talked about cases where these list methods actually change something in place and the assignment results in a none. This isn't one of those, and that's because dot copy intuitively, if you're making a copy of something, it doesn't make sense to say you're changing it in place. You are actually making a copy. So not all methods modify something in place. It sort of depends on how they're written and what their purpose is, and that's why actually reading the help for the methods and understanding how they work is always important. Okay, so now again I'm going to do x square bracket 0, so change that 0th element of x to capital D. And again print x is comma x and y is comma y. So again, by explicitly making a copy, x and y become distinct representations in memory, and changing one doesn't change the other. Now, in terms of getting your code to work, either of these approaches would do the same thing, right? So using y square bracket colon, specifying the whole range, kind of forces a copy, but it's not very intuitive to look at that code and think, oh, what we're doing there is making a copy of y. It's much more intuitive and creates much more readable and easily understandable code to use the .copy method because that contains the actual word .copy. And so it's clear when you read that, oh, it must be making a copy of y. Okay, so this brings us to the end of this lesson. Just to summarize, a list stores many values in a single data structure in Python, single variable name. You can use an item's index to fetch it from the list. Lists values can be replaced by assigning new values to specific indexes and positions in the list. We can extend lists by appending single items to them, or use Dell to remove items from a list entirely. We can also use extend if we want to add multiple items to the end of the list. So we can extend one list with another list using .extend. An empty list contains no values. Lists can contain values of different types. So we saw an early example of a list that contained strings, integers, and floating points. We also saw examples of lists that contain other lists. Character strings can be indexed like lists, and character strings are immutable, whereas lists are mutable. They're changeable. And finally, indexing beyond the end of a collection is an error. All right, that's the end of this lesson, and we'll see you next time.